20 centimeters starboard before I start to pull it out.
Copy that.
And Koichi, are you ready for GCA?
I'm ready, Hopper. Starboard 20 centimeters.
Starboard 20 centimeters.
Comes to motion. In motion.
I see good motion.
Copy.
And stop motion.
Thanks.
GCA complete.
GCA complete. Brakes on.
Copy, brakes on.
Okay, copy all, guys. And one last check for you, Hopper. Just verify for us that the large, small red is tethered to the pump module.
Large, small red is tethered. Rick has a visual on it as well.
Okay, my friend, you have yourself a pump module.
Okay.
So when you guys are ready, Rick working together, will you guys, Rick, keep the exit path clear. Koichi and Hopper, you have a go for GCA to remove the spare pump module.
Okay, Koichi, go please.
And Koichi, I'm ready for station aft.
Okay. Okay, Hopper, here comes the station aft motion.
And we're back with our downlink video capability from the International Space Station, just in time to watch Mike Hopkins wrangle the spare pump out of its stowage location on the starboard truss of the International Space Station, which is flying 260 miles over the South Pacific.
Good, nothing is holding it up. Continue motion, Koichi.
Copy that.
Hopkins being backed away, his booted feet in the portable foot restraint at the end of the Canadian-built robotic arm operated by astronaut Koichi Wakata from inside the Destiny laboratory.
Continue motion.
Copy that.
Good, continue, about halfway probably.
Yeah.
Continue most of the way. Looks like you're almost there.
See that.
Like you're out of the groove there, Mike. I think you're in charge now of that pump module. Continue a little bit more, Koichi, to clear the MLI.
Copy that, Rick.
Hold nice and stable, Mike. It looks good. You're doing a great job. Looks beautiful. Okay, you're clear of MLI by a few centimeters now. Clean, guys. Good job.
Okay, looks like it's another 10 centimeters to the published position.
Okay.
Okay, Hopper, this is a published X position, so I'm going to tweak in port direction and also zenith, both in 30, 40 centimeters.
Okay, I'm ready for motion.
First, I'm going to maneuver to station 4, about 50 centimeters. Here comes the motion.
My way, huh? Yeah.
Good view from Mike Hopkins' helmet camera looking down at the pump module that he has a firm grasp on. And below that, Rick Mastracchio at external stowage platform number 3, providing visual guidance cues for both Hopkins and robotic arm operator Koichi Wakata.
Koichi, we can proceed with the single joint at this point. And that is
yes,
16.
Copy that. We will. Okay, copy that. That's 16 at this time. Okay, Hopper, we had to go to use a single joint. So first I'm gonna, this is a 3-step single joint starting at elbow pitch, and I'll let you know before I start the maneuver.
Okay. Okay. Koichi, I'm in position. I'm right on the FHRC. You're well clear of it. Probably, well, I won't say well, you're maybe a meter from the FHRC.
Okay, copy that. Thanks, Rick.
I also worry a little about the solar array. I guess that's a lot further than it looks. Depends on which way you're going.
First one is the elbow pitch, and it should just move the pump module and hopper away from the ESP3 area.
Okay. Okay, I'll watch the lower boom, or upper boom, I should say.
And just for your awareness, we got more than 10 feet from the solar array, Rick. Thanks for that call.
Okay. Yeah, Koichi, I got good eyes. You're good to continue.
Hey, thanks, Rick. And hopper, I'm going to start the elbow pitch maneuver. This is a twin elbow pitch maneuver.
Okay, I'm ready.
Here comes the motion. Arms in motion.
I see motion. A good motion, moving away from the structure here.
Copy that, Rick. Thanks.
Mike, maybe a little pitch up, Mike, on the pump module, Mike. Okay, coming, just a little bit. That's good.
A great view looking down at the spare parts depot called External Stowage Platform number 3, the empty slot now that the spare pump was housed. And at the top of your screen, that large dish antenna is a spare space-to-ground communications antenna for S-band communications capability for the International Space Station.
Okay, hopper, elbow pitch maneuver is complete. Next one is a shoulder pitch.
Okay.
About 7 degrees.
I am ready.
Okay, here comes the shoulder pitch single joint motion.
Mike Hopkins taking a special sleigh ride on this Christmas Eve, holding the 780-pound pump module, the spare pump that soon will restore full cooling capability to the International Space Station.
Soft stow like little handrail on the MLI tent that you can wire tie those to just off to the side.
And hopper, shoulder pitch maneuver is complete. The next one is shoulder roll maneuver for 27 degrees.
Okay, I'm ready.
Okay, here comes the motion.
Flying from southwest to northeast across the Pacific Ocean, the International Space Station, its spacewalkers and other residents approaching the west coast of South America.
Oh, we are.
We like that on the cables, Rick, and once you get those both through that loop, if you could just wire tie them to that loop, that'd be perfect.
Copy.
Okay, Hopper, the single joint maneuver is complete. I'm going to set up for the next Joe cast.
Okay.
And Koichi, we're following you in step 17.
See that going to step 17.
That looks good, Rick, and just the objective here, just to kind of keep everything inside as we close that front door.
Right.
Okay, Hopper, the Joe cast is set, and this maneuver is for 4 minutes. And at the end of the maneuver, it will put you between the ELC4 and then the Columbus module.
Okay, I am ready.
Hopper, as we talked, I will start with the vernier, and
okay.
then if you're comfortable, we can bump up to course.
Roger that.
Okay, here comes standby.
See anything on this side?
Okay, Hopper, if you're ready, we can start the Joe cast.
Over here, huh? Okay, I'm ready.
Okay, Hopper, here comes the motion. Arms in motion.
Koichi Wakata now beginning to drive Mike Hopkins back toward the installation position at the S1 truss of the International Space Station, the starboard 1 truss segment, where the spare pump will be installed. Hopkins extracted the pump just a few minutes ago, about 14 minutes ago, after releasing a series of 4 bolts that completed the demating portion of today's activities. We're approaching the 2.5-hour mark in the spacewalk. The crew is operating efficiently as the International Space Station continues to fly smoothly with its occupants approaching the coast of Peru.
Of the MLI.
Nothing in work.
And we saw that you grabbed your adjustable from those electrical connectors, and just remember you have your, well, you'll see your adjustable up on top of the MLI as well.
Yeah, thank you. I do have the adjustable from the cables, and I'm heading to the MLI now.
Copy.
Meanwhile, Rick Mastracchio is cleaning up some of the wire ties and thermal insulation around the slot in which the spare was located on external stowage platform number 3. Ultimately, the degraded pump that was removed from the space station by Mastracchio and Hopkins during their first spacewalk on Saturday will be reinstalled in that stowage platform slot, but not today. The degraded pump that was removed, that went down due to an internal valve problem 2 weeks ago, will remain housed on a payload attachment bracket on the mobile base system of the International Space Station, the station's rail car system, if you will. That will be dispositioned during a future spacewalk, but not today.
And nice work, guys. Koichi, we copied the Vern. They're going to stay in Vern. We're about 2 hours and 31 minutes into the EVA. We're about 30 minutes down on the timeline, but no problem. We got plenty of consumables.
Copy that, Wheels.
Copy.
And our limiting consumable is battery on hopper at 8:35, so we're looking good, guys.
Copy.
Flying high over Peru, Mike Hopkins wielding the pump module, the spare pump, as he is being maneuvered into position by Koichi Wakata, operating the robot arm, the Canadarm2 from the robotics workstation inside the Destiny laboratory.
That would be awkward, yeah.
This just wraps around one of these handrails at the base of the frame, I guess, right? That's right. The middle, the long flap at the bottom wraps around, and I think there's some Velcro on the frame itself. I see it. Yeah.
And Rick, also, we see that you got the center strap, and just up on the sides as well, there's some Velcro straps.
Yep. Wrap it a present. Probably going to look like most of the presents I read. Not very pretty, but it'll be functional.
Okay, first geocast, Hopper's first geocast is complete, so I'm going to set up for the second geocast.
Okay.
Once Hopkins is maneuvered into the installation position with the spare pump, as he moves close to the open bay on the S1 truss or starboard 1 truss position where the spare will be installed, he will be aligning pins and guides to guide rails in that open bay before he begins to slide the truss into place. After that, he'll begin the process of bolting it in place with the 4 bolts to make sure it is secured. That will then set the stage for the hooking up of electrical connections and then the critical connection of the 4 fluid lines.
That's about all I can reach, Houston. I think it's mostly covered.
Okay, copy that, Rick. It looks clean. And now we're good to retrieve crew lock bag 2.
Copy.
And Rick, can you confirm that you got that adjustable from the top of the MLI and reattached it to you?
Yes, the adjustable from the top of the MLI is on my mini workstation.
Perfect, thanks.
And Hopper, this is Koichi. The next geocast is set, and we will maneuver you in vernier. Also, it's going to take about a minute, and at the end of this maneuver, we will put you about 4 meters in front of the pump module install position.
Okay, copy.
Ready?
I'm ready.
Okay, here comes the motion. Arms in motion.
And Rick, we see crew lock bag 2 on your BRT, and just as a reminder, you're going to pick up Hopper safety tether from there as well.
Okay. Crew lock bag is on board.
Well, Hopkins continues to be maneuvered toward the installation point for this spare that he has a firm grasp of. Mastracchio is in the process of stowing some tethers and a crew lock bag filled with tools on a crew equipment translation aid handrail on the rail car of the International Space Station's truss. 2 hours, 38 minutes into the spacewalk, the crew operating deliberately, but continuing to press ahead for the installation of this spare a short time from now.
I believe I got everything. I've got two adjustables, one red with a pip pin, one regular red on my mini workstation. I got a camera with an extra red on it. I got my PGT with a red and a socket, 2-inch socket. I got my BRT with a red and my waist tether. I've got my crew lock bag, work multiplier, fish stringer with several caps, and I think a wire tie caddy in there also, and a socket caddy. So if you're happy, I'll start heading back.
Okay, Hopper, the geocast is complete. You have a go to rotate the pump module.
Okay.
We copy that, Rick, and we copy your inventory. That looks like a good config. And we need you to also grab hopper safety tether. And we'd like you to attach that safety tether to your safety tether IRCM.
Hopkins is repositioning the pump module, the new spare, so that it is in the correct orientation for its installation in the starboard truss slot on the International Space Station. This places the quick disconnect connector points toward his head and the bolts toward his feet that he will be working on once it slides into place in its installation slot in Bay 1 on the S1 truss of the International Space Station.
Nice work, Hopper.
Okay, Houston, rotation is complete.
We copy. Nice work.
Get your attention, Rick. Yeah. Keeps you awake, doesn't it? All right, Houston, I've got Mike's safety tether attached to me.
Okay, copy that, Rick. You have to go to translate back to the SETA cart. Remember, we'll pick up that adjustable fare lead on handrail 3060.
Copy.
Mike Hopkins holding the spare pump module at the 2-hour 42-minute mark into the spacewalk. He will now spend a few minutes in this position. Koichi Wakata will begin a very slow and deliberate process of maneuvering him close to the slot, where he will gently guide this spare on a series of guide rails to properly install it, providing clearance of any fluid quick disconnect lines and the pump module jumper box. The ammonia lines inside the truss are hooked up to this jumper box, as they have been since Saturday's initial spacewalk, to maintain ammonia in the system, in the plumbing of the cooling system of the station, in the proper liquid state until the new spare arrives.
Okay, Houston. Get it on board.
We copy, Rick. Thanks.
Rick Mastracchio is now moving toward the installation position on the S1 truss of the International Space Station, so that he can provide visual cues for Wakata and for Mike Hopkins as they all work in tandem to align the spare to the guide rails that will enable it to be slowly slid into position and installed in the proper orientation in that slot in the starboard truss.
How we doing, Mike? I'm doing fine. I guess you're all waiting on me, huh? That's a beautiful view. Yes, we're over the Pacific. We're always over the Pacific.
Actually, you're directly in the center of the Atlantic.
That's why we shouldn't say things like that. Okay, I'm going to the Cedar car, right, Houston? Get some of the stuff off of me.
Affirmative, you're going to go to the... Stand by.
Yep, I'm on the inboard Cedar car, dumping off some of this equipment.
Copy that, Rick. We see you there, and you have to go to drop off Rick's safety tether. I'm sorry, Hopper safety tether, and then stow crew lock bag 2 on the square grids.
Copy.
Rick Mastracchio preparing to drop off some equipment which is not needed at the moment that was used for the extraction of the spare pump. He will drop that equipment off on a crew equipment translation aid, basically a parking place for some tools and other implements used for spacewalks on the truss. Then he will move very quickly to join Hopkins over at the installation position to provide visual cues once Hopkins begins the process of slowly guiding this large pump module into the guide rails on the starboard one truss of the station.
Let me get rid of this safety tether. It'll be good to start work again.
This view from Mastracchio's helmet camera as he prepares to drop off the tools that were used for the extraction of the spare pump. He then will make his way and join Hopkins at the installation position.
That, Rick, and we're going to forego the grabbing those, getting into the large ORU bag. Whenever you get the safety tether in place, go ahead and move to the install location.
So Mike's safety tether is just at the bottom of the Cedar cart, Mike. Okay. Just a couple feet from the handrail. Copy. And Houston, where do you need me next? Need you inboard. Copy. For the install?
Looks like we're going to work together for the install now, Rick, so inboard zenith or whichever corner of the inboard side.
Copy. Okay, in position.
Okay, yeah, and Rick, once we're in position, before we get started, give us a glove, please, on Rick, a glove and hap check.
Copy, stand by. And hey, Houston, I did see a pretty good MMOD strike out on the, I took some pictures of it, but it's well clear of us and well clear of any handrails, so I'll show you the pictures when we get back in.
Copy that.
And gloves and the hat, all nominal and no change.
Copy that, Rick, and could you give us just a real quick general location where you saw the MMOD strike?
It was right on ESP3, right on the Space Hab emblem, kind of under the pump module.
Copy.
Facing, I don't know which way it was facing. I was turned around pretty good.
Copy that.
And Rick, how's your safety tether? My safety tether's clear, Mike. It's a good idea, though. Let me put a fear lead on it. In case I got to go zenith.
2 hours, 50 minutes into the spacewalk, Rick Mastracchio reporting that his gloves look good. and his check of his helmet absorption pad behind his head, revealing that everything is nice and dry. No issues with either suit reported by either Mastracchio or Mike Hopkins. Mastracchio, interestingly, reporting that while at the stowage platform, external stowage platform number 3, on the starboard 3 truss segment of the International Space Station, he reported observation of what at one time would have been a strike of micrometeoroid debris that is not uncommon to strike station structures. In this 15 years that the International Space Station has been flying in orbit, he reported the strike near the stowage location and near the location where the pump module, the spare pump, had been housed.
Okay, sounds great, Rick. And just one more sweep over the work site area, make sure the entrance is clear for the pump module.
Can't work.
But the spare that you see in the grasp of Mike Hopkins at the end of the station's robotic arm is in good shape, being prepared for its installation on guide rails into its new home to replace a faulty pump that was removed by Mastracchio and Hopkins back on Saturday.
Everything looks good, Houston.
Okay, copy that, Rick. So, Hopper, we copied you have eyes on the GTEX, and Rick, you got eyes on the rails, and we're ready to hand off to Koichi and Hopper for GCA into the pump module install.
Okay. All right. Koichi, are you with us?
I'm with you guys.
All right. Okay, you can come station aft.
Okay, copy. Station aft. Slow motion.
Mike's probably going to need you to pitch up a little, but let's just hold off on that. Roger.
Arms in motion.
Copy. In here. Good motion.
Copy, continue.
Just hold that attitude, Mike. You look good. Roger. When you get closer, we'll maybe tweak it. Continue aft, Koichi.
Copy that, Rick.
Looks good. About probably almost 2 meters to go, Koichi. Plenty of clearance.
Copy, 2 meters to go.
Yeah.
Koichi Wakata flying the robotic arm with Mike Hopkins, his feet planted in a foot restraint at the end of the arm, holding the 780-pound pump module, the spare, and Rick Mastracchio providing visual cues to help fine-tune the guidance of the positioning of this pump module as it approaches its home on the starboard truss of the International Space Station, where it will be installed, bolted into place, and electrical and fluid lines hooked up a short time from now.
About another 20 centimeters.
20 centimeters to go.
Continue. Okay, go ahead and hold there, Koichi.
Dropping down.
Okay. So it seems like Mike's got quite a bit of pitch on it, so it looks like we need to go, the arm, go station port. I concur. Maybe 20 or 30 or 40 centimeters.
Okay, then station port 30 centimeters.
Yeah, approximately.
Here comes the motion.
So, Mike, what that will do is, like, as he goes port, you'll kind of pitch up. I concur.
Arms in motion.
Copy.
Yeah, that's looking much better.
Much better. Looks good, Koichi. In here.
Copy.
Continue.
Okay, that's about 30 centimeters.
Okay, a little bit more, maybe another 10. Continue. Okay. I think that's good, Koichi. You can stop there.
Okay, stopping.
Okay. Now I think we're ready to go station aft again.
Okay, station aft.
About half a meter, maybe a little less.
Half a meter, station aft. Here comes the motion.
Should be able to engage.
A very carefully choreographed maneuver here by Koichi Wakata, fine-tuning the positioning of the arm so that Mike Hopkins can steer the spare pump module into its slot where it will be bolted into place.
40 or 50 centimeters. Continue.
Hopkins being mindful to make sure the pump module steers clear of the jumper box for the ammonia system on the station. The ammonia lines hooked up to that jumper box since the faulty pump was removed on Saturday to maintain the flow of ammonia through the cooling system that is slightly degraded, that is soon to be restored to full capability, maintaining the ammonia in a liquid state as it awaits the arrival of this new spare.
Okay, Koichi, station aft, almost probably about a meter and a half.
Yeah, station aft a meter.
Yeah.
Here comes the motion.
Mike, I think you got to pitch it the other way, down. There you go.
Arms in motion.
Copy. Continue. Kind of let it get higher on your end, Mike. Towards your head. Okay.
Nice.
Yeah. Continue, Koichi.
Continue.
Mike, I'll let you decide what push it or you're letting the arm push it. Letting the arm push it for right now. Okay. I have to wiggle it every once in a while to slide in. Continue, Koichi.
Copy, continue.
Probably almost a meter still.
Roger that. Meter to go.
You comfortable with everything, Mike? Yep, I'm good. Okay. Continue.
Copy, continue.
Okay, here come the second guides. Hold up, stop, Koichi, stop.
Okay, stopping.
Hey, hold back a little bit, Mike, if you can. Okay, coming back. Okay, and I'll set down here and
stand by.
Push it in.
Stand by just for a second here, guys. Stand by. Koichi, we're coming up on some ready comm. We're going to lose comm, and I need you to take down these PGT settings when you're ready.
Okay.
Okay, Koichi, when you're ready, Bravo 3, clockwise 2, and we're going to install the pump module in this order. Bolt 1, 4, 3, 2, expecting 17 turns.
Okay, copy. Bravo 3, clockwise 2, pump module bolts in the order of 1, 4, 3, 2, 17 turns.
That's a good copy, and you have a go while we're in the LOS to drive those bolts.
Copy.
And Koichi, we need you to Koichi, we need you to record torque and turns when that occurs on the bolts.
Okay, copy. Record torque turns.
Good copy. Go to continue. Thanks, guys.
Okay.
Thanks.
Roger that. And Rick, I am ready to...
Doug Wheelock, the spacecraft communicator here in Mission Control, reading up bolt and torque settings to Koichi Wakata on board the International Space Station. We are going to be heading into a loss of signal here shortly so that the crew can continue with the process of installing and bolting the spare pump in place in the absence of a downlink television capability. A great view from Rick Mastracchio's helmet camera at the starboard truss installation position of the International Space Station as we have now hit the 3-hour mark in today's spacewalk.
Okay, hold on 1 second.
Hold on. Okay, stopping. Stop.
Okay, let's get Why don't you get yourself lined up with the bolts? Okay.
15 centimeters, hopper.
Let's continue.
Continuing. You're going forward.
That's good.
Stopping.
Okay. Port is complete. We can continue aft now.
Okay, I'm ready.
Oh, that's so much easier.
Okay, here comes the station aft motion.
Copy.
Arms in motion.
A very delicate process of sliding the spare pump onto these guide rails, making sure that pins and alignment guides are carefully positioned.
Stop motion.
Stopping.
I believe it's got to go in maybe another inch or so, Mike. There you go. Perfect. And Houston, if you're there, have a pump module in position. So Koichi, GCA is complete.
And Koichi, we hear you on Spaceman 3. We copy.
Okay, you're ready. GCA complete. And the brakes are on, hopper.
Copy. And give me PGT settings, Koichi.
PGT setting Bravo 3, clockwise 2. Start with bolt 1.
Okay, copy.
The next step here, now that the spare has been installed in its slot in the bay that was vacated by the removal of the faulty pump back on Saturday, Hopkins and Mastracchio will now work in tandem to bolt this spare in place. A series of 4 bolts, 17 turns to torque on each of the 4 bolts.
We're just ready on Space Ground 1, so we do hear the EV crews at time to time. But we may need you to relay some messages.
That's what he said, yeah. Clockwise 1 set.
Clockwise 2.
Clockwise 2. Clockwise 2 is set. Coming under you, Mike. Copy. And Koichi, can I get you to come GCA station port another 10 centimeters?
Okay, copy. Station port another 10 centimeters. Here comes the motion. Motion. Copy. What's about 10 centimeters?
And stop motion.
Okay.
GCA complete.
Complete. And the brakes are on.
Copy that. Okay, we're turning on bolt 1.
Copy that. Expect 17 turns on bolt 1.
Okay, 16 turns. I got almost 18 turns and 16 on the torque.
Copy. 18 turns and 16 on the torque. Bolt number 1. Bolt number 1.
Copy.
Next one is bolt 4.
It's going to bolt 4. Okay.
Clockwise 2.
I was on Bravo 3, or Bravo 2.
Yeah, setting is Bravo 3, clockwise 2.
Okay.
And we'd like to go ahead and retorque at Bravo 3 on bolt 1, guys.
18.4 on the torque.
18.4 on the torque.
That's affirmative.
Here in Mission Control, reporting that bolt 1 has now been installed properly. 3 more to go. We're at the 3-hour, 7-minute mark in the spacewalk. The crew working efficiently and deliberately, running a bit behind the timeline after beginning the spacewalk at 5:53 a.m. Central, 6:53 a.m. Eastern today.
And Houston, I got the fault with the low torque.
Copy, stand by.
Okay, copy, stand by.
And that's on, confirm that's on bolt 4, Hopper?
That's affirmative, bolt 4.
Okay, copy, stand by. Okay, Hopper, reset and we'll reattempt at Bravo 3.
Copy, inward. Ready?
Hopkins working on the second of the 4 bolts that will permanently affix the spare pump module in the starboard 1 truss slot on the International Space Station.
Okay, got another fault with the low torque.
Copy, stand by. How many turns?
I had another 8 turns. So
Copied another
first
8
one
turns.
was approximately 7 turns. That one was 8.
Okay, stand by, Hopper.
Copy.
Copy, Hopper. We got 15 turns, but we want to try this again, reset and back on Bravo 3, and like to get good torque and green light.
Copy that. And again, another fault. Low torque, going 9.7. Approximately another 3 turns.
Okay, copied another 3 turns. Stand by. And Hopper, did you get the torque reading on the PGT?
Yeah, the torque is 9.7 is what it's saying on the actual.
Okay, Hopper, we would like a power cycle of the PGT, then reattempt at Bravo 3.
Copy, inward.
Here in Mission Control, Flight Director Dina Cantella with her back to the camera. And on the far right of your screen, the lead spacewalk officer, Allison Bollinger, are discussing pistol grip tool torque settings. so that Mike Hopkins can drive the second of 4 bolts in place to hold the spare pump securely in its new slot on the starboard truss of the International Space Station.
The whole time, Hopper, until it torques out.
Roger, Wilco. Okay, we got a green light, 18.3.
About an hour ago, this spare was removed from its stowage location on a stowage platform holding spare parts on the International Space Station. Mike Hopkins, holding on to the spare, was maneuvered at the end of the station's robotic arm from the stowage platform location over to the installation location on the starboard truss of the complex. He slid it into a set of guide rails in the bay, the open bay, where the spare pump now resides, and is in the process of bolting it in place. At the 3-hour, 12-minute mark into the mission, we've had a temporary loss of signal. We'll be reacquiring communications with the station just a few moments from now.
How large are you back at this time?
Checking.
And Houston, we got green light, 18.3 on the torque, 17 turns. Bolt 3.
Copy that. Hopper on bolt 3, and now go ahead and remove the round scoop from bolt 2 and transfer that to Rick. And then, Rick, once you get that, then we'll have you do some work in the bags.
Okay, well, I'm already in the bag, so just hang on to that torque multiplier, Mike. I'll get in a minute. Right. And Houston, am I clear to remove the large, small rat?
Yes, you're clear, Hopper, to remove the large, small rat.
Okay. Round scoop is removed. Large, small rat's removed. Go to my mini workstation.
Copy.
And Houston, am I clear to drive bolt 2?
You have a go, Hopper. Same settings, bolt 2.
Bravo 3, clockwise 2 is set and turning.
Copy, and Rick, you can take that, go back to the large ORU bag. And we'll stow the round scoop in crew lock bag 1.
Copy, stand by, on my way.
Yeah, let me know
okay,
when you're...
Houston, bolt 2, green light, 18.3. 17 and a half turns.
Okay, great work, Hopper. Thank you. And you go to stow your PGT now.
And all 4 bolts now have been driven in successfully by Mike Hopkins, so the spare pump is bolted into place in its slot in the starboard 1 truss bay of the International Space Station.
Copy.
Next up will be the mating of a series of 5 electrical connectors, and Rick Mastracchio working to vent this spare pump in preparation for the mating of fluid connection lines and the flowing of ammonia into the new pump.
it now? Yeah, just, okay. Got it. Want to give me that? I'll get it. Yeah, stand by. Let me get it. Get a handle on myself here. I got it.
And guys, as you're working there to get
your large, small.
As you're working there to get configured, we're about 30 minutes down on the timeline, so we're going to press forward with QDs and forego the electricals for now, and we'll come back to those.
Okay. I appreciate it. Got it. Okay, so.
And as the flight control team watches the clock, we're going to reverse the order of tasks here and move right into the hookup of the fluid connection lines, a series of 4 connectors.
Copy that. You had a 50% chance there, Rick. We'd like to scoop back in crew lock bag 1, and you can go ahead and bring the vent tool to the work site as well.
Okay. And work.
So once again, we're going to hook up the 4 fluid connection lines. There are 3 1.5-inch fluid connections and 1/2-inch fluid connection line. This will enable ammonia to flow into the spare pump. Once the valves are opened, following the connections being made, and once the electrical connectors are mated, some 35 pounds of ammonia will be flowing from the ammonia tank assembly that's adjacent to the spare pump into the pump itself.
I'm ready.
Checking. And Hopper, you have a go to with Koichi to GCA into position for the vent tool.
Okay, Koichi, I need to come. Station zenith, 5 centimeters.
The vent tool that's being discussed will be used by Rick Mastracchio to hook up to the M3 fluid connection line on the spare pump. And once the valve is opened to that particular line, that will enable stored nitrogen that has maintained a pressurized state inside the spare to be vented out, ultimately to be replaced by the flow of ammonia.
About 30 centimeters.
Station starboard, 30 centimeters. Here comes the motion. Sounds in motion.
Good motion.
Okay, good motion.
Motion.
Continuing.
Houston, the scoop is in crew lock bag number 1, and I've got the vent tool on my mini workstation. And Koichi, stop motion. Sorry, Mike. Okay.
Okay, we copied that, Rick. That sounds like you're in a good config there, and just position yourself for QD ops for the venting.
Okay, and Koichi, I want you to come station aft, about 5 centimeters.
Copy, station aft, 5 centimeters. Arms in motion.
Good motion. And stop motion.
Okay.
And I'm going to need you to go starboard just another 5.
Starboard 5 centimeters. Arms in motion.
motion. And stop motion.
Stopped.
GCA complete.
GCA complete. Brakes are on.
Copy.
Okay, guys, when you're ready and in position, we'll...
Okay.
When you're ready and in... Go ahead, Rick.
I have the vent tool, handing it to Mike. Your place to read this? To the bail is what I got it. Okay, I'm ready. Copy.
Okay, copy, Mike. On that vent tool, you're going to remove the plug. It should have a lanyard on it. And that's just pulling back on the release spring, so squeezing the trigger.
Hey, Mike, before you do that, okay, you got it, man. Good job. Okay, I've got it. I'm going to leave this loose until you connect. Roger that. Okay. Moving the vent plug. I see a lanyard. And it's removed.
Okay, copy that, Hopper. Okay, we're going to mate the QD on the vent tool to the M3 male connector. And I'll read you steps.
Copy.
Let me know when you're in position and ready. Copy. Position and ready.
Copy. Okay, I'm looking in the vent pool. Okay, hold on 1 second, too, before you do that. Let me get this guy reasonable config on this end. Okay. And I don't see any pod, Houston. Good fingers, good plug, good outer casing.
Okay, copy that, Hopper. So the caps are removed, and we heard a good inspection on both ends. Verify the female QD in the vent, on the vent tool that it's ready to mate. Check D10 button is up.
Is up.
And the forward white band is not visible.
And there's no forward white band.
Okay, shouldn't be any side loads, but assess and counteract as you the side loads as you mate it. And you are a go to mate the QD and check that the forward white band is visible.
Copy. And I have a forward white band visible.
Copy, Hopper.
Button is up.
Say again that last part, Hopper.
D10 button is up.
Okay, perform a snapback test and check that the forward white band is visible again.
And complete, and it is visible.
Okay, staying clear of the button and the release ring, perform a pull test on the QD.
Pull test complete.
And a visual gap test.
And gap test looks good.
Copy that, and stand by. Rick, can you confirm that the other end of the vent tool is secured?
It is secured. I've got a adjustable on it, and then it's to the fish stringer, actually. So it looks clear. It looks clear of everybody. It's pointing relatively station forward. And I'm going to GCA starboard another 10 centimeters here, Koichi.
Copy that, Hopper. Station starboard 10 centimeters.
Hold on now, Koichi. Hold on. Hold on. Let me check the GTEX. Okay. Okay, you could if you stay really low, you can go maybe 5 or 6 centimeters. Okay, 5 centimeters, Queechy.
Station starboard 5 centimeters. Here comes the motion. Arms in motion.
Continue a little more.
Continue.
Okay, is that enough, Mike? That's good. Okay. Stop motion. GCA complete. Okay, so
GCA complete.
Okay, Mike. So just stay with your head forward like that, because you're only 5 inches from those G-techs. Okay. Copy that.
Okay, and Rick
and the arm brakes are on.
Copy. And Rick on the.
Sorry to step on you there, Queechy. Rick just wanted to check on the securing of the end of the vent tool. Did you go to the fish stringer because there's not a handrail there?
Did you go to the fish stringer? I could wrap it around the seat of handrail if you really want.
We're checking.
Yeah, if I could do it. It's done, Houston.
If that's our preference, Rick, if you can reach that handrail, just make sure we don't put a bend in the vent tool, any kind of sharp radius.
Yep, it's done. It's wrapped around the seat of handrail, the adjustable lids, and back to the vent end of the tool.
Okay, perfect. Nice work, Rick. And Hopper, stand by for opening the valve.
Okay, I'm ready.
Okay, on that valve, we have a go for opening the valve, and I'll walk you through those steps. We have a go for opening the valve, and I'll walk. Prior to and during bail movement, assess and counteract any side loads, Hopper. Depress the detent button.
Roger.
Push the bail forward, forward to the full open position.
Copy.
And in the full forward position, you see the aft white band visible.
Looks good.
Aft white.
Stand by.
This is Mission Control Houston, approaching the 3.5-hour mark into the mission, into the spacewalk for today by Hopkins and Mastracchio. A vent tool has been hooked up to the so-called M3 fluid connection line on the new spare pump just installed in its slot in the starboard truss of the International Space Station. Once the valve is thrown open, it will take about 60 seconds to vent nitrogen out of the spare pump in the precursor to the mating of fluid quick disconnection points to 4 connection lines to enable ammonia to flow into the spare pump.
Yeah, no problem.
Okay, guys, we're ready for, and we have a go for closing and demating that QD. So, Hopper, when you're ready.
Okay, I'm ready.
Okay, move the bail full forward to the full open position. Check aft white band. Check aft white band visible.
Visible.
Check detent button is fully installed, that it is up, and it can be depressed.
Up and can be depressed.
Okay, and same warning on the prior to and during bail movement, assess and counteract side loads. And while depressing the detent button, move the bail toward the open position with significant force.
Okay, inward.
So the crew now being instructed to complete the work that was just accomplished to vent the new pump module. Nitrogen that had maintained pressurization inside the spare pump has now been vented, setting the stage for the mating of 4 fluid connection lines to the new pump module.
In the closed position, forward white band visible, detent button is up.
Okay, nice work. And we have a go for demate. So just assess and counteract side loads, pull back on the release ring, and demate the QD. On the release ring and demate.
Demated.
Okay, Hopper, copy demated.
Can you just attach the other red to that?
And the release ring, Hopper, you verify the release ring is retracted and the forward white band is not visible. The release ring is retracted.
And no forward white band visible. Release ring is retracted.
Copy that, and just inspect both ends of that QD, please. Debris, damage, or anything else you might see.
No plug looks good.
Okay, and go ahead and reinstall the plug in the vent tool.
Okay. Reinstall the Backing inward. And Mike, can you put that on the wire tie, the other end of it? It's kind of flopping around here. The vent end of it. Yeah. Thank you. I guess give it to me, I guess. And Houston, the vent plug is reinstalled.
Okay, great. And let's go ahead and stow that vent tool back in the large ORU and close the lid, Rick, if you can. ORU and close the lid.
Copy and work. Got it. And Houston from EV1, have a good glove check and tap check.
Copy, thank you. We're about 30 seconds out from a short LOS, a short dropout. You guys can get in position for the single G-Tech, and we'll meet you on the other side.
Hey, copy that. Just watch your back, Mike. Okay. I'm going to wait until you're close before I... Yeah, it's going to be a couple minutes here. Okay. Gonna mess with your release bags. Okay, vent tools in the bag. Copy. Bag is closed. Vent tools cozy.
Thank you, Rick. You sound excited about that.
Must be made of gold.
Copy that. And the Hopper, for your positioning, we're going to be working M1 and M2 first. So if you need a GCA from Koichi to be in position for M1 and M2.
Yeah, copy that. I'm going to wait till Rick's here just to make sure I don't. Okay, Mike, I'm here. So stay with your face on the hardware there. Okay. What do you want to do? Get higher, or what do you want to do? I want to come station nadir. Nadir? Yeah, nadir's fine. Okay, so Koichi, I need to come station nadir 10 centimeters.
Copy that. Station nadir 10 centimeters. Here comes the motion. Arms in motion.
I see good motion.
That's about 10.
Continue.
Continuing.
And stop motion.
Stopping.
GCA complete.
The brakes are on.
Copy. Okay, we're in position, Houston. I'm next to the G-Tech and the fish stringer.
Perfect. I got a couple cautions here for you guys, and let me read these. Remember the small line. Only move that small line when depressurized. Also, when mating and demating the small QD, only input loads at the QD. Do not handle the line. Also, the zenith and nadir fluid lines M1 and M4 cannot handle non-axial loads. How copy?
Copy.
Okay, guys, working together. We're working on the G-Tech removal from the M1, M2 lines. That should be the single G-Tech.
With Aki on 2.
Okay, copy that. Ben,
hey, Coach, just a heads up, if you're following along, we're on page 15 in the EVA procedure, getting close to meeting the QDs.
Yeah, you can
we're going to tag off on Space Ground 1, but
just
after
stay like that. There you go.
we're getting close to that message 430
Should be off your right
Alpha.
shoulder. Oh, okay, there it is. Don't put any stress on it. Okay, Doug, go ahead.
Yeah.
Okay, guys, we're gonna remove the G-Tech from the M1, M2 lines.
Yeah, we're in page 15.
Rick, the objective here, we're going to get the G-Tech removed and then put the G-Tech on the fish stringer and grab one of the large skids for Hopper.
We'll tag up, but we're getting close to message 430 Alpha. Just wanted to give you a heads
put a red on it?
Okay, I was reading that procedure, so yeah, thanks for the heads up.
Okay, there's a rat on the G-Tech, and I'm ready to release the adjustable to the fish stringer. Ready, Houston?
We're ready.
Okay, there's the adjustable loose. And you need to uncinch it. Deck is released from the adjustable. And uncinch it. Where's that? Oh, there it is right there. That's it. Hold on. Okay. Get a little more uncinching going. Okay. I've got it. Okay, you have it. I got it. The G-Tech is removed, Houston.
Copy that, Rick, and we'll go ahead and retrieve one of the large spids and get that ready on Hopper.
The G-Tech's on one of the adjustables on the fish stringer.
Copy that.
Comes a spit, Mike. Okay.
Okay, guys, once you're in position and ready, we're going to be working with the M1 line first. On the line, it's the nadirmost line. It should be labeled Foxtrot 44 as well to the M1 connector on the pump module.
Hey, copy that. Okay, M1. So how do you want to do this? One at a time we're bending these over, or both simultaneously?
It's up to you guys, Rick. You can do them both to allow you access to the work area. Whatever's good for both of you, you can put them both down.
Okay. Your call, Mike. I think one at a time, don't you? Okay. Yeah, I think that'll be okay. I think you'll be able to work like that. Yeah. Okay, Houston, I'm looking at the female end of M1. You get fingers, get plugged, no fog. Same thing on the male side of the QD. Looks clean.
Okay. Stand by. And can you confirm on the line there should be a label that says Foxtrot 44?
Foxtrot 44/M1 is the line in Mike's hand, yes.
Perfect. Thank you, guys. Okay, Mike, that line on M1, we got the caps removed. I heard you guys' inspection. Looks like no debris or damage. Verified the female QD is ready to mate. The D10 button should be up.
It is up.
The forward white band not visible.
Emmerich, it's going to have to come. Yeah. Yep, hold on. How's that? You finish your checks with Doug before we move it anymore. Okay. And what else do we have on our checks?
Okay, I heard you call the D10 button is up. The forward white band should not be visible.
It is not visible.
Copy that. Heard you guys already assessing and counteracting the side loads prior to mate. And as you're assessing and counteracting those loads, you have go to mate the QD.
Hey, Rick, I need to, like we have a little bit, needs to come to my left. Come to your left. Okay. So nadir. So can you put the forward?
This is Mission Control Houston, now 3 hours 44 minutes into today's spacewalk by Mike Hopkins and Rick Mastracchio. The two crew members working in tandem, now about to begin the process of mating 4 fluid connectors, basically reversing the process that they did back on Saturday when they demated these same connectors to remove the faulty pump from the starboard truss of the International Space Station. They'll go sequentially, the M1, M2, M4 and then M3 connection points, the first 3 being 1.5-inch wide connections to enable ammonia to flow into the tank, into the new pump from an ammonia tank assembly, and the M3 being a 1/2-inch connection. Once these 4 fluid lines are hooked up in sequence, then we will go back and hook up electrical connections before ammonia can begin to flow from the ammonia tank assembly that sits adjacent to where the new spare was installed a few minutes ago by Mike Hopkins and Rick Mastracchio.
No work, no reach. Looks to me like it needs a pitch down. So the hose end needs to come up. Okay. You agree? Yeah. Stand by. Nope.
For those just joining our coverage, Mike Hopkins and Rick Mastracchio began the second in the series of spacewalks to replace a faulty pump on the International Space Station and restore full cooling capability to the complex. This spacewalk began at 5:53 a.m. Central Time. The crew moved out of the Quest airlock, gathered their tools and all of their equipment, and began the process of removing the spare pump from a stowage location on a stowage platform holding spare parts on the starboard truss of the station. Mike Hopkins was in firm grasp of the spare pump as he was maneuvered at the end of the station's robotic arm a short distance over to its installation position, the robot arm being driven by Japanese astronaut Koichi Wakata from the robotics workstation in the Destiny laboratory. Very slowly but surely and carefully, Hopkins and Mastracchio guided the new spare into a series of guide rails in the bay on the starboard one truss of the International Space Station. They vented nitrogen out of the spare pump and now are in the process of hooking up 4 fluid connection lines.
Okay, perform a snapback test.
Complete.
Okay, and that forward white band is visible again.
It is.
Nice work, guys. Okay, Hopper, on the QD, staying clear of the button and release ring, perform a pull test on the QD.
Copy. Full test.
Copy, and visual gap test.
And good gap test.
Okay, nice work, guys. Okay, we're getting ready to set up to open the QD now, Hopper, and have that SPID ready.
So the first of the fluid lines, the M1 line, has been hooked up. We're preparing now to open the valve on that particular fluid line. 3 more to go after that.
Switch spacer is installed.
Prior to and during bail movement, assess and counteract side loads.
We're about 5 to 6 minutes away from regaining a television downlink capability from the International Space Station. Station currently flying 260 statute miles over the South Pacific.
Okay, Hopper, okay, and Hopper, we want to stand by here. We're coming up on a short LOS dropout, and we'll call you on the other side. Stand by here.
Okay.
It'll be about a minute and a half before we call you back.
Roger. Sure. Oh, yeah. Good call. Ready? Good job, thanks, man. Okay. I got a bunch of you out on ESP3, man. I removed the wire tie already down here. Just got that one up there.
Okay, guys, we're back with you. How copy?
And that's loud and clear.
Okay, sounds great. Rick, since we cycled that the vent tool on M3, we'd like you to kind of put some eyes on the M3 as Hopper opens this valve and just make sure nothing's leaking out of the M3 QD. How copy?
Okay. Yeah, I'll back up a little. I got good view of it.
Okay, copy that. So, Hopper, prior to and during bail movement, assess and counteract side loads as needed. Depress the detent button and push the bail against the forward spid spacer.
The SPID being referred to by Doug Wheelock, the spacecraft communicator, is an acronym for the Spool Positioning Device, which is essentially a mechanism that helps to rigidize these connectors and prevent any internal leakage from occurring through the flow of ammonia that would overpressurize the internal design of the ammonia lines themselves.
A portion of the aft white band is visible.
Yeah, that's the image.
Hopper, can you confirm that the forward spid spacer is fully seated?
It's fully seated.
Yeah, Houston, that white band, even with a spid, is usually just slightly visible. I've seen that many times.
Okay, copy that, Rick. We think we're in a nominal config. Nice work on that.
I agree.
And Hopper, as long as that aft part of that spid is spacer is installed, you can remove your ret from that spid.
Okay, it's removed.
Okay, copy and stand by. We're doing some work on the ground.
Okay, copy.
We'll get you another spid. And I was gonna think about doing electricals maybe while we're waiting for other stuff.
And Rick, we want to do M2 before we do the electrical, so stand by.
Okay, yeah.
Okay, guys, we have a go for mating only, the M2, and it should be line number Foxtrot 45, mating to M2, mate only.
And I see Foxtrot 45.
All right. Hold on.
I can go ahead and mate without the
let's do it. Let's do it. That spit just decided to get tangled up on my adjustable. Okay, ready.
Okay, and also the spid handy, you said, Rick?
Yep, I got one right here.
Okay, copy that. And we just got to go to open as well. So we're going to mate the QD and then open. So on that M2 line, when you're in position, I'll read you the steps, Hopper.
Okay.
All yours. Okay, ready to...
This is Mission Control Houston, 3 hours, 55 minutes into today's spacewalk. Hopkins and Mastracchio working diligently on the second of the 4 fluid connection lines for the new spare pump module, the cooling pump that was installed in the starboard truss of the International Space Station a short time ago.
Okay, copy.
The thermal systems officer here in Mission Control reporting the early indications are that the new spare that was installed is holding good pressure.
Verify the female QD is ready to mate. The detent button should be up and the forward white band not visible.
Up and forward white band not visible.
Okay, assess and counteract side loads prior to mate. And you have a go to mate the QD.
Okay, copy that. And I feel like it needs to pitch down a little bit. And my left again.
Your left. Okay.
Your end needs to come.
And pitch down, which when you mean that,
That means push yours inboard.
push it down, huh?
And I think you need to come nadir a little bit.
Nadir. Okay, see the TA clamp is kind of, but okay. TA clamp says go zenith.
Okay.
But
try zenith.
Good.
Nothing's hung up back there, right?
Now you know what it is? It's P clamp this time. There you go. All these clamps are hanging up. There you go.
No. Needs to pitch down.
Down means pull.
This view from Mike Hopkins' helmet camera showing those three connection points, J3, J4, J5, those are electrical connectors that the crew will work to hook up a short time from now. They're working on the second of the 4 fluid connection lines through which the ammonia coolant will flow once the valves are opened following the completion of those 4 fluid line connections and the mating of the electrical connectors.
Okay, Hopper, perform a snapback test.
Okay, that's complete, and forward light band is still visible.
Nice. Staying clear of the button and release ring. Perform a pull test.
Pull test is complete.
Visual gap test.
And the visual gap looks good.
Okay, nice work. And Rick...
and a good connection now for the M2 fluid line. 2 down, 2 to go.
You haven't already.
Already got it.
Perfect, and we're ready when you're set, Hopper. We're going to open the valve when you're ready for those steps.
I am ready.
Install the forward skid spacer after the release ring.
Complete.
Prior to and during bail movement, assess and counteract side loads as needed.
Copy.
Depress the detent button and push the bail against the forward skid spacer.
Work.
Push the button before you put stress on the bail, Mike.
Yeah, the button's not... button is not pushable.
Not depressible.
Depressible. And Houston, the button won't push.
Copy that, Hopper.
Got a good forward light band. Is it complete or is it not fully full? Kind of a band look kind of small to you.
It could be small.
Yeah.
Push a little more.
Yeah, stand by.
Okay, Hopper,
Tell me when you're ready.
take the bail full aft and see if you can depress the button.
We'll push the bail full aft. That did the trick. Thank you.
Okay, copy that. While holding that, now you can depress the detent button and move the bail against the forward skid spacer.
Check that spin, Mike. You know, check where you put it. There you go.
Okay, forward skid spacer is installed.
Okay, Hopper, can you say again on the SPID?
Yeah, it's installed, the forward skid spacer.
Copy that, and when you move the bail against the forward skid spacer, you have a go to install the aft skid spacer.
Okay, here comes, pushing the button, moving forward. Okay, it's against the forward skid spacer.
Copy that, Hopper, and go ahead and install the aft spacer.
Mark. Okay, outfit spacer is installed.
Okay, copy that, Hopper, and you can remove your RET from there. Okay, nice work, guys. Now we're going to work to remove the G-Tech from the jumper box.
Copy.
And again, stow that on the fish stringer, Rick.
Okay. And Koichi, are you ready for some GCA?
I am ready.
Okay, I need to go station forward about 20 centimeters.
The G-Tech acronym referenced by Doug Wheelock in that communication to the crew from Mission Control here in Houston is the acronym for the generic thermal EVA cover. It's basically an insulation bag that was placed over the pump module jumper box on Saturday when the faulty pump was disconnected and removed from the starboard truss. This jumper box has the fluid connection lines hooked up to it to maintain the flow of ammonia in the proper state until this spare can be hooked up and all of the connections completed.
20 centimeters. Here comes the motion.
The crew working methodically through the reconnection of the ammonia lines into the new spare on the starboard truss. A good view of the two spacewalkers. On the right, Rick Mastracchio, wearing the suit bearing the red stripes. And on the left toward the bottom of your screen is Mike Hopkins.
GCA is complete.
Now 4 hours, 4 minutes into today's spacewalk.
And you have a rep to it, Rick?
I do. I'm right into the G-Tech.
Okay.
At the top of your screen, in that shot that we just saw a moment ago, was the European Space Agency's Columbus module. Now back, and there it is again. It is hooked up to Harmony, the Node 2 of the International Space Station, along the port side of the International Space Station. And again, back looking at the area of interest, the work site at which Hopkins and Mastracchio are currently involved in the connection of ammonia lines to the new spare.
Stand by.
The International Space Station flying from southwest to northeast at an altitude of 260 statute miles, moving across the Pacific Ocean, soon to cross Central America, the Caribbean Sea, and the east coast of Cuba.
Ready? Yeah. You pull it right off?
Yeah.
I'm ready to it.
And Station Houston on the big loop, just a tag up with the EV crew and Koichi. So next, we're going to be closing the valve on the pump module jumper M3. After that, the ground will be commanding the valves For Koichi, message 430 Alpha will be in effect in case we lose comm with you guys. How copy?
Okay, Aki, copy. I have a message 430 ready here.
Copy that.
Okay, Koichi, I'm going to GCA into position to actuate this valve.
Okay, I'm ready for GCA.
Okay, I need you to come station zenith, 20 centimeters.
Copy. Station zenith, 20 centimeters. Here comes the motion. Arms in motion.
Good motion.
Copy, good motion. That's about 20.
And stop motion.
Okay.
Go station starboard.
Okay.
10 centimeters.
Station stop at 10 centimeters. Here comes the motion. The motion.
Begin motion. And stop motion.
Copy.
Okay.
All right,
Hold on. Yeah, let's talk big picture. Doug, can you give us big picture of what we're doing?
Okay,
What order?
yeah, I'll give you the order here. We're going to be working with the M3 connector, which is a large connector on the jumper box first. We're going to close that valve, and then we have some steps on the ground, and when we give you a go, we're going to close the line on the M4 line on the jumper box as well. And then, then first, when we get to the D-mates, we're going to be taking the small line off first and connecting it, mating it to M4, followed by the M3 line.
Okay, so Doug, can we bend the lines at this time? We have to wait till you bend them, so we should leave the jumper exactly where it is and don't bend the lines yet, right?
Affirmative, Rick. We leave the lines right where they are until we're finished venting. Thank you.
Okay. And the cinch that we have around M3 will stay in place.
Affirmative. They'll stay in place for right now.
Okay.
So, Rick, do you think you'd be able to, using the bell lever tool, actuate that so I can push the button for you?
I could try, Mike.
Don't think you're stable enough?
No.
And this particular connection at the 4-hour, 10-minute mark into the spacewalk that is hooked up to this jumper box was connected back on Saturday after the faulty pump module was disconnected and removed. This enables ammonia flowing through the cooling system on the starboard side of the station to remain in a fluid state, in the proper liquid state, while it is flowing back and forth through the ammonia tank assembly. That is a huge assembly that lies adjacent to the pump itself, which stores about 600 pounds of ammonia. Once all of the fluid connections are hooked up to the new pump, the spare, that was just installed a short time ago, some 35 pounds of ammonia will flow into the new pump, and over a period of hours later in the day, the system will be pressurized with nitrogen from a nitrogen tank assembly on the starboard side of the International Space Station that stores nitrogen at 3,000 pounds per square inch. Later tonight, somewhere in the 8:30 p.m. Central Time neighborhood, the entire pump will be activated, but there will be an operation called a bump test that will be executed right after the flow of ammonia begins into the new spare. Once all the fluid lines are connected, this bump test essentially is a brief exercise that will move the valves internal to the new pump and check out all of its systems in a brief preliminary test for the thermal systems officer here in Mission Control to prove that the new pump is alive and well. Bill Kowalczyk is the Spartan officer. That is his call sign of the thermal systems officer here in Mission Control for the Orbit 2 team of flight controllers under the direction of Flight Director Dina Cantella.
Okay. Stopping. Good.
No, continue.
Be continuing at starboard. Arms in motion.
And stop motion.
Stopping. Okay, hopper brakes are on.
PA complete. Thanks, Richard.
In the true definition of the International Space Station, a Japanese astronaut operating a Canadian arm with the assistance of a Russian cosmonaut to help two American astronauts in the void of space conducting this spacewalk. A true international effort to restore full cooling capability to the International Space Station.
Let me go up high again, see what I can do up here.
Hey, Houston.
If all goes as planned, the repressurization and activation of this spare pump this evening will enable cooling loop A to be restarted. It will be put back into service, and then slowly but surely throughout the day on Christmas Day, we will see the reintegration of the heat exchangers in the
large line, the M3 line.
International Space Station to bring cooling loop A fully back online. At that point, sequentially, all of the systems that were affected over the past 2 weeks by the partial cooling loop shutdown will be re-enabled and placed back under the cooling authority of cooling loop A.
Visible.
Okay, I have an aft light band visible. That was full forward.
Okay. Check the detent button is fully installed, that it is up, and it can be depressed.
It cannot be depressed.
It should be able to be depressed. And Hopper, just...
It is not depressible.
Okay, copy that. Stand by. Okay.
Shooter used to spit.
Okay, Hopper, two-handed here. If you could push that valve full forward and see if you can depress the button then.
Okay. No joy.
Okay, stand by.
Off the bail control tool.
Yeah.
Mike Hopkins on the left, Rick Mastracchio on the right, finding a bit of resistance in the demating of the third in the series of fluid connection lines. This one hooked up to the pump module jumper box to provide a temporary flow of ammonia through the plumbing on the starboard truss of the International Space Station during the swap out of these pump module components.
And guys, we're just thinking a minute down here. Can you guys take a look if we had Hopper just securing the box, both hands on either side of the box just to secure it? Rick, could you get up to operate that bail?
Yeah, I can, but I don't think I could put the force that he's putting into it. He's putting a lot more force than I'll ever be able to do as a free floater.
And I'm putting significant force into it.
Copy that. Stand by. And Hopper, we wanted to make a suggestion. I know you were using the bail drive lever against the two bales. We'd like you to try it down onto the bail boss down in the side of the QD and to the center line of the forward bail. It may give you better leverage.
Yeah, there you go. That's it.
Capcom Doug Wheelock and Flight Director Dina Cantella consulting with lead spacewalk officer Allison Bollinger here at Mission Control, basically fine-tuning the technique that Hopkins is using with the tools he has at his disposal to try to demate this fluid line from a pump module jumper box.
It is not going. I am putting significant force into it.
Copy, stand by. Okay, Rick, we're going to send you over to the large ORU bag and to retrieve the control tool.
I'm already there. Bail control tool.
Should be in crew lock bag 1, Rick.
Yep, it's in my hands. I got it. Bail control tool is on board. A mini workstation. Coming your way, Mike. Excellent. Houston, we have the bail control tool. Mike has it.
Okay, copy. We're going to go ahead and install that thing. I got a warning for you here, though. You see the screw inside there. We call it the Acme screw. Do not touch or tether to that screw due to potential sharp edges on it, and avoid pinch points. Okay, we're going to install that onto the QD, and let me know, Hopper, if you need me to walk you through steps.
It just slide right over
Yeah,
there.
you might have to adjust the screw length, though, Mike.
And Hopper, you'll see the latch tabs and just.
Go ahead and walk me through it, Doug.
Try it now. It's leaning forward because of the ret. There you go.
Okay, you look like you got it there. Nice work. Now, as Rick had mentioned, just engage that bail claw over the QD bail and just adjust it in or out as you need it.
Don't put any force on it until they let it. Roger.
And Hopper, as much as you can, try to stay away from the threads on the screw.
Copy. Okay, it's against the forward bail.
Okay, copy that. Stand by. Okay, Hopper, we're going to do in quarter turn increments and check the button. So a quarter turn, check the button, and go up to 10 turns and let us know if you get the button.
Okay. And you want to turn it right there? One turn. Yeah. No.
We need you guys to keep track of the turn count as best you can as well.
All right, we're at 2 turns. There's about 3 turns right there. No push. Yeah. Continue? Yeah. You still want us to continue?
We can continue all the way up to 10 full turns, Rick.
Okay. 3.5. 4. Good. Still not. 4.5. Oh. 5. Still no good. Go ahead. Nothing. 5.5. Nothing. Nothing. 6. No door. 6.5. No. 7. No. Let's stop and think about what we're doing. 7 turns, Houston.
Copy, Rick. Stand by just a second. We're talking as well.
We'll continue. Yeah. A little nervous.
And guys, we're discussing down here. We may have you hold. We're just a few minutes out from eclipse, and we can take some steps from the ground to vent out that line too as well. So stand by.
Okay. Okay.
This is Mission Control Houston, approaching the 4.5-hour mark in the spacewalk.
Okay, guys, we're going to continue to 10 full turns, Rick, and again, rechecking and trying the button at every quarter turn.
Copy. Go ahead. Awesome. 7.5.
Mike Hopkins and Rick Mastracchio continuing efforts to try to demate a stubborn fluid line connector from a pump module jumper box to which it was connected back on Saturday when the faulty cooling pump was removed from the starboard truss of the station.
Stop right there.
Copy.
You can see on the left the first 2 out of 4 fluid connection lines have been mated. Valves have been open. Ammonia not yet flowing.
8.5 turns.
Stand by.
Houston.
Okay, guys. Okay, let's go one more quarter turn.
There you go.
Not able to push it in anymore.
Okay, stand by.
We're at
8 3/4.
8 3/4.
Almost at the end of that Acme screw. That seems like a lot.
Okay, guys, we're going to take it all the way to 10 turns. Again, we're going to see if we can get some movement in that button.
Okay, hey Doug, so for this Acme screw, there may be 4 threads left on the back side of that screw, just so you know how far along we are.
Copy that.
There's 9. Oh. And I'll tell you, the torque on turning the Acme screw, and the torque on it is pretty high. I'm just turning it with my hand, but there's 9.5. 9 3/4.
Okay, stop there, guys.
Okay. You may have gone too far.
Flight control team now talking about having Hopkins and Mastracchio back off a bit on the turns with this contingency tool that they broke out to try to free up this particular fluid line from the pump module jumper box.
Good, here we go.
We're thinking maybe that we pushed it a little too far forward and got the other end of it.
Right here. So there's about 9 right there, Mike.
Okay, keep going.
I'm going to go kind of slow here. It's right around here. There comes 8.5. Nothing?
Nothing. Gone.
8 1/4. There's 8 right there. Nothing. Fingers getting tired, huh?
Yeah. Right there.
All right, Houston, we're at 8 turns. Still no dry.
Okay, copy, stand by.
One thing we never expected.
Getting it off the jumper box.
Yeah.
This is Mission Control Houston, 4 hours, 32 minutes into the spacewalk. The flight control team here continuing to brainstorm on possible suggestions on how to free up this stubborn fluid line that is hooked up to the pump module jumper box, one of two such lines hooked up to the jumper box. The crew is trying to free up this third in a series of 4 fluid lines. 2 fluid lines have already been hooked up to the new spare. 2 fluid lines that were installed on this jumper box to maintain the flow of ammonia in the proper liquid state during the interim period between the removal of the old spare and the installation of this new spare. That's what's proving to be a stubborn task for Hopkins and Mastracchio.
Okay, guys, we're going to try a little bit of a tap technique. We'd like you to use, before we go to the scoop, the big hammer, we're going to try to use a large hook, like off of a waist tether, and just see if you can gently tap on the button hopper and see if we can free it up.
Okay, can I use the bail lever?
That's acceptable.
We have no idea what forces we're putting in with this bail control.
All right, can we back it off a little?
That's to Houston.
No joy with the tap here at 8 turns, right? There's
7 3/4.
7 3/4 turns.
And we're go to back it off a little as well, Rick.
Stand by, Rick. Let me try that. One more.
There's 7.
And Hopper, whenever you're able, we'll take an assessment. When you found that sweet spot, how much of the button were you able to push down?
It wasn't much. I mean, I just felt a little catch, but it didn't go all the way down. That makes sense.
Copy that.
So I felt it start to go, but...
Okay, copy that. We're still discussing, so stand by a second. We think maybe we might be on the forward side of that band, so maybe we'll back off pressure and try this again from the beginning. Stand by.
Okay.
This is Mission Control. Once again, the issue being discussed here is how to successfully demate one of 2 fluid lines hooked up to a pump module jumper box. This box was installed for 2 of the 4 fluid lines that enable ammonia to flow into the ammonia pump itself to keep the ammonia flowing in an interim state, in the proper state, through the cooling lines on the starboard truss of the International Space Station during the period between the removal of the faulty pump that occurred on Saturday and the installation of the new pump today.
We'll take one more turn to 4, Rick, and that'll put us at halfway on the bail. Halfway to the sweet spot, I should say.
Yeah, that's 4 right there. Significantly less torque on the Hopkins screw.
Okay. Try that button again, Hopper.
Actually, back it off a little more. Yeah, it started to move. Can you back off a little bit?
3.5.
Okay, come forward.
Forward? Forward, Mike?
Yeah.
Back to
Just trying
4.
to see if I can find it.
There's 4.
Okay, stop there. Back off again. Back off to 2.5. Yeah. 2.5.
Back it.
Yeah.
Try tapping it too.
And as you guys
As
you guys are working this hopper, if you do get the button to push down, hold it down. Hold it.
Yeah, copy that. And it'll go flush against that surface of the release, right?
Yeah, it'll look almost flush.
Yeah.
There's 3 turns what we got right now.
Yeah. Yeah. So we're at 3 turns. I haven't found it. Back off a little more. You want to go forward?
Your call, I can't tell, man. I go, there's 2.5. The force on the valve control tool, the torque is almost nothing, man.
Okay.
So it seems to me.
Go forward.
Forward, yeah. Back to 3.
Yeah.
Tight forward.
Yeah, forward.
3.5.
Okay.
3/4. There's 4, back to 4.
Austin, KS, KW.
Okay, go another 1/4.
Which way? Forward?
Forward.
Okay. Four and a half.
Okay, it's...
Did you get it?
Oh, it's coming. Okay, so Houston, it seems like it's moving down. But it's not like a release, if that makes sense. It's just, I'm slowly able to get it to go in.
And Hopper, real quick, could you confirm that the button is fully installed? Just do a turn on it.
I can't turn it. It doesn't budge.
Okay, copy.
Great.
And Rick, just to get us in sync, you're about 5 turns right now?
I think about 4.5.
Okay, copy that, 4.5. And we're still discussing, stand by.
It's lower. There's never been a, like a release, like it just pushes in real easy.
What if we started pulling the bail out?
But I'm wondering. I hold it. It's down enough.
Maybe.
Okay, guys, we're going to try something here. Hopper, I would like you to get in position to hold the button with your thumb, depressing it, and Rick, back off all of the force on the screw.
You do with that, Mike?
Well, that's going to give me... And Houston, I'd like to go ahead and just use the end of the bail lever.
Yeah, copy that, Rick.
A little more leverage and...
That's fine. Okay. That's fine, Hopper. Copy that.
Okay.
You ready?
Yep.
Back it off.
Pushed. It's in.
Okay, hold on to it.
The button's in, Mike?
Button is in.
Okay, hold it in, please.
Yep. That's like the hand's on.
Okay.
Have some snow. Okay.
Okay,
Take the tool
Rick,
out.
copy that, Rick. And when you get that tool out, you can just take that bail to full aft. Close the valve.
Yes, we got full aft, white forward light being visible. We do have snow coming out.
Copy that. Check forward white band. We heard it was visible. Check detent button. What's happening with that, Mike? Is it up?
And stand by.
Doesn't look fully up.
There, it's up.
It is good.
Detent button is up.
Okay, copy that. Nice work, guys. Okay, the valve is closed. Stand by.
Wow.
Holy smoke.
Good job.
LOS will meet you on the other side. Short LOS.
Okay. Yeah. Looks like it stopped. What's all that?
Yeah, I don't know if it's just bouncing around where that's coming from.
I don't see it.
There's still a little bit.
Okay.
Yep, still a little bit. One every second or so.
Copy.
Okay, as we're doing some venting on the ground here, guys, are filling. We'll go ahead and hold here, and we'll take your assessment on what ammonia you saw leaking.
Okay. We've seen maybe about one very small, or a couple millimeters, flakes coming out every second or two.
And Hopper, can you say could you see where on the bail, where on the QD they were coming out?
I could not.
I would say the forward side, but it's not real clear.
Yeah.
And do you still see a leak?
I'd say forward.
Do you still see any leaking, or has it dissipated?
Yes. It's about.
Still see any leaking or
yes.
dissipated?
It's about one every second. One little snowflake a second.
Copy that. We're taking a look to see if maybe that could be residual in that spring cavity. Stand by.
Copy.
And for both of you, could you tell if any of the flakes contacted your suit?
Absolutely.
Yeah.
And for Koichi, vent is in progress, so you can stand down on your steps, contingency steps.
Okay, copy that.
This is Mission Control Houston. So after...
you can see some of that flakes coming out now in the camera.
Yeah, we don't have your cameras right now.
Okay. Yeah, And I still see some coming out.
Copy, Hopper.
They look small snowflakes.
Houston, we see snow. We see the snowflakes coming from the aft side forward. Looks like your vent is coming towards us.
Ah, that's where it's coming from.
Copy, Houston.
Copy that, Rick.
Yeah, some larger.
Yeah, they're just completely surrounding us now.
Copy, Rick. And we have no video, Rick, so we'll just take your continued description.
Okay. Okay, they're pretty good-sized particles, much bigger than anything we've ever seen. See that big one going by you, Mike?
I do, and they're coming.
Look like they're coming inboard of the pump module, right all around the pump module. Looks like. I can't see them everywhere where the light is, but they're hitting the wrist cluster of the SSRMS. They're enveloping Mike, probably enveloping me also. Yes.
Yes, they are.
Big chunks. Big chunks.
Copy.
1/4 inch diameter. Lots of little ones, some big ones. Maybe slowing down, but hard to tell.
Yeah, we're looking at about a 6-minute, 4.5 to 6 minute vent process. So.
Okay. Happy. Which way is it venting?
Yeah, we hope that. I mean, where we're seeing it come from is where we would expect to.
Stand by.
Seems like a good vent.
It's likely coming from the aft side of the truss, Rick. It's maybe bouncing off some things and coming back your way. So.
Yeah, definitely.
This is Mission Control Houston. To quickly recap, after utilizing some ingenious techniques, Mastracchio and Hopkins were able to finally demate one of the fluid lines hooked up to a jumper box, an interim box to maintain the flow of ammonia through the cooling system in a liquid state during the swap out of the old faulty pump module for the new spare that was installed earlier today during the spacewalk.
Doesn't seem to be sticking, though.
No, it seems to be bouncing all over the place, yeah.
I agree.
At the time that this bulky fluid line was finally demated from the jumper box, the crew noted some ammonia flakes emanating from the female side of the quick disconnect interface. Some of those flakes might have bounced off their suits. We'll determine that a bit later. The flight control team now in the process of determining whether or not to hook up this particular line to the new spare. It appears that we will.
Hey, Rick.
Sure.
While we're waiting,
Yep.
and still wondering if we could move those other two electricals before we put in four. And
Okay. Yeah, let me slide over.
don't know if you can get up underneath there.
Yeah, you could GCA me maybe a little bit.
Okay.
Once again, the third in the series of fluid lines disconnected now from the pump module jumper box. We have noted some flakes of ammonia coming from the female side of that disconnect interface. Flight Director Dina Cantella conferring with her flight controllers, determining whether we give the crew a go to continue with the published procedures and hook up this third in the series of fluid lines to the new spare that was installed in the starboard truss.
I don't see any snow anymore, do you?
No, I don't.
Copied that it stopped snowing. That's good news, guys. We're closing down those valves now, and the vent is complete.
Copy. I do have a rep on the jumper box right now.
Okay, nice.
Good idea.
Nice idea. That's great, Hopper. That's going to be our next call. Way to go. Okay, so guys, together, we're getting ready to close the valve on the small line, on the M4 line on the jumper box. And let me know when you guys are in position for closing that valve.
So after some consultation, we're pressing ahead with the connection of the third in the series of fluid lines to the new spare.
I'm ready if you want to.
Okay, copy, Hopper, on that on that M4. Yeah, on that M4 on the jumper box. Move the bail to the full forward position. And rotate the locking collar to the unlocked position.
Full forward. Rotate. Unlock.
Copy. Check F white band is visible.
Visible.
Check the detent button is fully installed, that is up, and it can be depressed.
Fully installed. Doesn't want to depress.
It looks to me like there's snow coming out of M4.
I agree.
Okay, stand by.
Forward side?
Yeah, I still see snow.
Out of M4, and it's closed. I mean, open. Or is it coming from M3 still?
I can't tell.
Okay, we evacuated that M4 line.
M4.
Yeah, it's still got.
And we vented that line, guys, so it should dissipate. Let us know if you see that.
Okay.
How's the button?
Flight control team is monitoring the reports from the crew in the absence of a downlink television picture right now from the space station.
Okay, say again, Rick.
Okay, aft flight band is visible, detent button.
Go ahead, Mike.
And this is Hopper. Aft flight band is visible, detent button is installed and can be pushed.
Okay, perfect. Prior to and during bail movement, assess and counteract the side loads again.
The crew a moment ago reported some residual flakes of ammonia continuing to emanate from the so-called M4 fluid line, the third in the series of 4 fluid lines that contain ammonia, that are in the process of being hooked up to the new spare pump module that was installed in the starboard truss of the International Space Station. The issue with the flakes of ammonia began at the point at which Mastracchio and Hopkins used a series of techniques and contingency tools to coax a stubborn fluid line, this M4 line, free from a connection on the pump module jumper box to which it had been installed on Saturday when the old pump, the faulty pump, had been removed.
Okay, copy that. And can you guys give us your assessment on the if the snow is gone?
I still see a little bit of snow coming out of M4.
Concur.
They're very small flakes.
Pretty, yeah, every 5 or 10 seconds maybe.
Concur.
Okay, copy that. And that may be just residual. The first thing we're going to do. First thing we're going to do is demate the M4, but stand by.
Okay.
I think the snow has stopped.
I still see some.
Okay, guys, we're go for demate on the M4. That's a small QD. Go to demate from the jumper box, and I'll walk you through those steps when you're ready, Hopper.
Okay, I'm ready.
Assess and counteract side loads prior to demate. Pull back on the release ring and demate the QD. On the release ring and.
Okay.
Beautiful. Good job.
Okay, it's demated.
Okay, nice work, guys. Check release ring is retracted and the forward white band is not visible.
And there's a small piece of the forward white band visible. Just the forward edge of it.
Okay, discussing, stand by.
See that in the disc?
Discussing, stand by.
I can't see it from my angle.
I can't take a seat in my WBS.
Hopper, go ahead and pull back on the release ring again, or push back on the release ring. Release ring again.
Copy. And when I do that, Doug, it still wants to pop out.
Okay, copy that. And it's just a piece of the forward white band, you see?
That's right.
Okay, copy that. Stand by. Okay, guys, we have a go to continue with just a piece of that forward white band visible. Our next step is mating the M4 to the pump module. So we're working to get in position to mate that QD.
So,
Gonna have to GCA.
gonna bend
Can you stabilize that?
M4?
Yeah.
Well, let me try. Why don't you just let it go? Well, what happens when you let it go?
This is Mission Control Houston. We just passed the 5-hour mark into today's spacewalk.
Okay.
Yeah.
As we continue to look at the clock, and now we'll be evaluating decontamination procedures for the crew, since it appears as if some residual flakes of ammonia did come in contact with their suits during the demating of this third in a series of 4 fluid lines from a pump module jumper box. We're in the process of mating the third in those series of lines to the new spare pump module, and then we'll get on with the disconnection of the fourth of the fluid lines, the M3 line, which is the 1/2 inch, the smallest of the fluid lines from the pump module jumper.
30 seconds to a short handover.
And stop motion.
Stopping.
And Rick, can I get you to put a rec on the jumper box? It's a bit of a pull it.
Yeah.
Okay.
Okay, let's go station port another 10 centimeters.
Okay, station port another 10 centimeters. Here comes the motion.
That's a good motion.
Copy.
Okay, you can stop motion.
Hmm?
All right, let's go station.
Here in the flight control room, the thermal systems officer has told Flight Director Dina Cantella that he is go with pressing ahead and having Mike Hopkins run through the steps to demate the fourth and final fluid line from the pump module jumper box. It will be connected to the new spare pump to complete the connection of the 4 fluid lines a short time from now.
Okay, stop motion.
Stopping.
GCA complete.
Copy, GCA complete. Brakes are on.
Okay.
Just don't lean back too much, Mark.
I'm just trying to get a look inside. And Houston, just what I can see inside of the M4 connector, female end, it doesn't, I don't see any pod.
Okay, copy that, Hopper. And working together, but just no axial loads in that M4 line. We are a go to mate the QD to the pump module jumper, or the pump module.
Okay.
Pump module, my bad, sorry, Kate. And when you're in position, I'll read you those steps, Mike.
I'm in position, ready to go.
Okay, to M4, we got the caps off. You've already inspected both ends of the line, heard that. Verifying that the female QD is ready to mate. Verify the detent button is up.
It is.
The locking collar is in the locked position, and the forward white band is not visible. We understand that a little portion of it may be.
Okay, and it is in the locked position. And again, just a small part of the forward white band is visible.
Like you want the speed?
I think we can mate it first.
Okay, go ahead.
And I'm ready to continue here.
Yeah, we are not going to open the valve, the M4 valve yet, so we don't need the SPID yet.
Okay.
Okay, Hopper, when you're ready, you guys both assess and counteract side loads prior to mate, and you have a go to mate M4.
Copy.
Back with downlink video from the International Space Station. This view from the helmet camera of Mike Hopkins as he prepares to mate the third of the 4 fluid lines, the ammonia lines, to the new spare pump module that was installed a few hours ago.
No. And Houston, at that test, I'm a little leery about, I don't have a good position for my hand.
Okay, copy.
Do that without releasing it.
Stand by.
Copy.
Yeah, you can't touch the line, so there's not much to it.
Right, I can't.
How's the gap?
Gap looks good. There is a little bit of movement in it. I expect to see that.
I don't know.
And Hopper, I don't know if you can get the bail drive lever kind of in the side there just to move that release ring and see if it'll snap back. Hey, stand by just a second, Hopper. Stand by.
Okay.
Scratch things up.
And Hopper, we think you may have already checked that release ring. Can you verify?
In terms of a snapback?
Yeah, for the snapback.
I did not get a good snapback.
Okay, copy that. So just stabilizing the QD with one hand, kind of holding the axial force in so the QD doesn't demate. Use the blunt end like we saw you, the blunt end of the bail drive lever. Try not to make any contact, if possible, with the male QD, and see if we can counteract with one hand and get that snapback test with the other.
Spacecraft communicator Doug Wheelock instructing Mike Hopkins how to use this particular tool to ensure that we have a tight mate of this third in the series of 4 fluid lines to the new spare pump module.
And staying clear of the button and the release ring, just do a pull test.
Okay, and I have a pull test.
Copy in the visual gap. I heard you said the visual gap test looked good as well.
It does. The only thing I'll say, Houston, is there's a little bit of play that I can push it forward and it comes back. Maybe 1/16 of an inch, or 32nd of an inch. So there is some play fore and aft.
Copy, stand by. And guys, we're getting words that this may be typical. Rick, do you remember when we disconnected that line? Was there some play in it? Do you remember?
I can't say I remember, Doug. Sorry.
Okay, copy that. Stand by.
Copy.
Okay, guys, we'll take a glove and hap check from both of you when you're able.
Hey, Houston, from EV1. The hap check is normal. On the glove, the left index finger, that thread that was up near the end of the digit, there's a little bit more of that showing. But I don't see any damage to the Vectran underneath.
Okay, copy, Hopper. That's acceptable.
EV2 nominal, no change. No change on EV2.
Copy, Rick.
This is Mission Control Houston, 5 hours and 12 minutes into the spacewalk. 3 out of 4 fluid lines now connected to the new spare pump module.
And we're going to be working with the M3 line now.
What's left is the so-called M3 line. This is a this is the final fluid line that is hooked up to the pump module jumper box. Again, that jumper box utilized in an interim state to maintain ammonia flowing through the plumbing of the cooling lines of the space station on the starboard truss in an acceptable fashion during the period between the disconnection of the faulty pump back on Saturday and the installation of the new pump today. There was difficulty with the third in the series of fluid lines, the M4 line. It just refused to budge from that pump module jumper a short time ago. When we finally were able to get it disconnected, a small number of ammonia flakes were detected by the crew. We believe that playing it safe and per the flight rules, we will have to conduct a decontamination procedure for the crew before they are able to re-enter the International Space Station. But that's forward work a short time from now. The task at hand now is to disconnect the fourth and final fluid line from the jumper box and to hook it up to the new pump module.
Can you squeeze the handles and I'll pull back on the jumper box?
I can.
Perfect. And so we have go to demate that QD, and I'll read those steps when you guys are ready.
Ready. We're ready.
Okay. Assess and counteract any side loads prior to demate. Pull back on the release ring and demate the QD.
You made it. Demate it.
Looks pretty clean.
Sure.
And there was
caps are on the jumper box.
There was